Alrighty, let's look at a couple more examples. So this is example 4, and that is to find a number t such that the point t, comma 3t is on the line connecting the point, containing, the points 1, -1, and -2, -5. Okay, so we've got a line, and we're trying to determine a number so that t3t is on that line. Okay, so our first step is to determine, the equation of the line that's going through those 2 points that are given. So to do that, we're going to find the slope using our slope equation. So that's as simple as plugging -5 in for y2 and -1 in for y1. I'll go ahead and write the slope equation down again so you don't forget it. M is equal to y2 minus y1 over x2 minus x1. And the 2's and 1's don't really matter. The order is just as long as you keep the points together. So this is a point pair, and that's another point pair. So we have -5 is going in there, and -1, use another color, going in there. Oops. Erase that. -1 is going in over there. Oh, that's a highlighter. Shoot. Pen. There we go. Oh well. You get the gist. -1 is going in over here, and we have -2 minus 1 from the x values. So 5 minus -1 is -4. 5 minus -1, that's 5 plus 1. -5 minus -1, that's -5 plus 1, which is -4. And then -2 minus 1 is -3, so that's going to give us 4/3 for our slope. And then we need to pick a point, doesn't matter which one of these, 1, -1, or -2, -5. And use the point slope form. So plugging in -1 right here and -1 right here into our point slope form, which I'll write is y equals mx minus x1 plus y1, we're going to have an equation for our line. So the next step is to use the point that's that has the unknown t in it, and we're going to plug that into our equation for x and for y. Let's use some colors. So there's our x, and there's our y. We're going to plug those in for x and y, and then solve it for t. So after doing that, so there's y, and there's x. We just have to get t by itself, so do some algebra to do that. So distribute that 4/3, and that's going to give us 4/3 t minus 4/3 minus 1, and 3t is still on the left. Take away 4/3 t from both sides, so let's go ahead and do that. So minus 4/3 t and minus 4/3 t from both sides, and that's going to cancel with this guy, and we can combine the -4/3 and minus 1, so minus 4/3 minus 1 is equal to minus 4/3 minus 3/3, which is just -7/3. Okay, and so there's our -7/3 right there. So now let's go ahead and combine 3t minus 4/3 t. So 3t minus 4/3 t. So this is 9/3 t minus 4/3 t. And 9 minus 4 is equal to 5. So this is 5/3 t on the left. So we have 5/3 t equals -7/3. And now we just multiply it by the reciprocal of both sides. So let's go ahead and do that. So this is times 3 over 5 times 3 over 5. The reciprocal of 5/3, rather. So that's going to cancel those 3's, and those 5's are going to cancel, and that's just going to give us t by itself. And then on the right-hand side, those 3's are going to cancel, and that's going to give us -7 over 5 as the final answer. So t equals -7/5. Okay, let's look at another example. Determine the point of intersection, if there is one, between the two lines, 2x minus 3y equals 5, and y equals 1/2 x plus 1. So I'm going to show you two different methods. The first method is called substitution, and then the second method is going to be called elimination. So we'll go through substitution first. So the first step in doing a substitution method is to solve one of our equations for one variable. You can solve it for x or for y. Now I'll give you a second to take a look at one of the equations. One of them is already solved for a variable. Do you think it's the red equation or the blue equation? Oh, you're correct if you said it was the blue equation. That has already been solved for y. So we don't have any work to do. We have accomplished step 1 already just by recognizing that the second equation is already solved for y. Now we substitute it into the other equation wherever we see that variable. So in our other equation, we can see that there is y right here, and so I'm going to replace y with 1/2 x plus 1. So that gives us this equation, 2x minus 3 times all of 1/2 x plus 1. When you're doing the substitute step, it's very important that you remember to use parentheses. I'm going to misspell this. Parentheses. I think I got it right. So use the parentheses when you're doing your substitution. This way you remember that -3 is actually going to distribute to both 1/2 x and to 1. And if you forget to use the parentheses, you will get something that's incorrect. So now we solve this one equation with one variable in it. It's just has x in it and numbers. So to solve it, you can go through any number of ways to do it. I went and distributed the -3, and that gave us 2x minus 3/2 x minus 3 equals to 5. And then you can combine 2x minus 3/2 x, so 2x minus 3 over 2x, that's 4 over 2x minus 3 over 2x, which is equal to 1 over 2x. And then if you add the 3 over to the right-hand side, that's going to cancel here, and you're going to get this equation, 1/2 x equals 8. And simply that gives us x is equal to 16 after doubling both sides. Times 2 and times 2. Okay, so that's half of the, this is the vast majority of the work. We've got half of our point of intersection. We know that the x-coordinate is 16, and we just need to figure out what the y-coordinate is. And so we can plug that into either of the original equations, either the red one or the blue one, to determine the y value. So if we use the blue equation, for example, we plug 16 in for x, and then that gives us y equals 1/2 times 16 plus 1, which is 8 plus 1, which is just equal to 9. So there's our y value. The point of intersection is 16, 9. And if you want to check your work, you just have to make sure that it actually is in the other equation, the one we did not use. And we can check that simply by doing 2 times 16 minus 3 times 9 equals to 5, I believe. So this is 32 minus 27, and that's 5. So good, 5 is equal to 5. So that it is in fact on both equations, or satisfies both equations, so it's on both lines. All right, so here's another method for doing this, and this is called the elimination method. You can kind of choose your favorite between the two. For elimination, you're going to want to get both equations into standard form. So the red equation is already in standard form. For the blue equation, we just have to do a little bit of work to get there. So what you can do is if you multiply everything by 2, that's going to give you 2y equals x plus 2. And then subtract x from both sides, and that's going to give you minus x plus 2y equals 2 after taking away x. And then multiply everything by -1 so that our x is positive, and that gives us x minus 2y equals -2. Okay, so there's our standard form equation for the blue line. Okay. So now to do elimination, once we've got them both in standard form, we have to multiply one or both equations so that the coefficients, those are the numbers in front of the variables. So coefficients are like the -2 or the -3, etc., etc. Multiply one or both equations so that our coefficients of one variable are equal but opposite in sign. Okay, so they are the same absolute value but have opposite signs. Now, if we look right now, we can see that that's not true yet. We have 2. If I look at my coefficients, this is a coefficient that's 2, and this is a coefficient that's 1. They're not equal and opposite signs. And likewise, we have a coefficient of -3 for the y and -2 for the y. Those are not equal and opposite signs. Okay, so we have to multiply one or both equations to get this into that state. So let's leave the red equation alone. We're going to take the blue equation and multiply everything by -2. And what's that going to do? That's going to turn our equation into -2x plus 4y equals to 4. Now it's exactly the same equation, just everything has been doubled. It's going to give you the exact same line. So now that we've got our equation kind of changed a little bit, it's not a different line. It's the same line. It's just all the values have been doubled. We can add the equations together to eliminate the variable x in this case. So when we add them together, 2x minus 3y equals 5, and minus 2x plus 4y equals 4, we're going to see that the x's cancel, and the y's are going to combine, and the numbers on the right-hand side are going to combine. So minus 3y plus 4y is equal to y, and 5 plus 4 is equal to 9. And without any more work, we have now determined that the y-coordinate for the intersection point is 9. So the last step is the same as for the other example, is we know what one of our coordinates is. We just have to plug that into one of the two equations to solve for the remaining variable x in this case. So we plug 9 in to the second equation, for example, but we could also plug it into the first and solve this for x. So take away, multiply everything by 2. Gives us 18 equals x plus 2. Take away 2, minus 2, and that's going to give us x is equal to 16, which is the same point we had earlier. point of intersection is still 16, 9. All right, so there's two different methods for finding the point of intersection. You either use substitution or elimination, and it's kind of your choice, whichever you prefer, whichever you're more comfortable with. All right, so that ends our lesson, the first lesson, examples. Hopefully you enjoy the videos, and please give me feedback as to if I'm going too fast, too slow, these are too long or too short. This is my first time doing it in this way, so I definitely need the feedback, so feel free to let me know. Okay, I'll see you guys in class.